Hello, and welcome to our webinar, The 3 Levers of Getting the Most Out of Amazon Redshift and AWS. Before we start our webinar, I'd like to go over a few housekeeping items. We will have a Q&A at the end of this webinar, but you can input your questions at any time. We are recording this webinar, and we will send you the recording 2 or 3 days after the webinar is over. There are 3 presenters today. And the first presenter is Taylor, and I'll have everyone introduce themselves.
Hi guys, I'm Taylor Holland from Heroku, where I run public cloud operations.
My name is Fabio Beltramini, and I'm a customer success analyst at Looker.
My name is Dylan Morrison. I work on the Looker platform team. I just wanted to give a quick background on Looker and AWS before we jump into it. So Looker and AWS have a long-standing and pretty close relationship. As most of you know, Looker is a data platform that allows business users to ask and answer questions directly through Looker's interface. Looker queries databases directly with SQL, and because of this, we're better able to leverage the raw power of Amazon's databases and querying engines, which are always getting faster and more performant behind the scenes. Given the strong level of interest from our customers in AWS and our close relationship with AWS, we decided to team up with their product team to construct an array of Looker blocks, which are pre-built data models and dashboards designed to help users manage their cloud performance and investment. So together, we decided to focus on 3 of the most critical components of cloud management, those being cost and usage, admin and optimization, and security and monitoring. And with that, I'll let Taylor take it away and talk about how Heroku uses Looker to minimize cost and monitor usage.
Hi guys, Taylor again. So today I'm going to, for Heroku's bit, talk a little bit about AWS optimization focused on EC2. Before I get there though, a little bit of background on Heroku. So we run a platform as a service hosting over 1.5 million apps, 300K active developers, and app profiles that range from simple mom and pop app shops or simple developer apps to complicated HIPAA compliant enterprise systems. And we do that with 3 stacks: our shared runtime, our private runtime, and our database services, as well as all our underlying orchestration applications. When you transpose this to Amazon, this looks like 2,500 linked accounts, 60,000 EC2 nodes at any given point in time, 120K distinct per day, 20,000 ELBs, 10 petabytes of S3, et cetera. And one of the things we do as a platform as a service is try and think about capacity management so that you don't have to, one of the abstractions we provide versus Amazon itself. When we think about optimizations in general at Heroku, we sort of have 3 tranches that have a range of complexity. There's sort of the basic setup or configuration optimization, things like security parameters, role configurations, resource tagging, and enabling CloudTrail logs. And then you move into the resource versus demand sizing. For the given workload or storage need you're looking at, are you picking the right plan or product from the AWS use case? And then what we're going to talk to you about today is capacity planning and optimization. And this is, at aggregate, once you've selected the right plan. When you get into bigger workloads, more volatile workloads, how do you think about capacity planning, and how do you use reserved instances to help mitigate cost? Just a quick insight to our scale. You can see what our EC2 demand is by hour here. So we're growing pretty quickly. We have a pretty volatile demand, which makes it pretty important for us to have insight and be able to gather data around this and make decisions around this. Quick capacity planning 101 before we jump into our Looker use case. If you look at this hypothetical provisioning versus demand, with demand being the black line and provisioning levels being the purple step function, this is often what you see for an unmanaged EC2 capacity. This introduces a couple business risks, right? Once you go beyond your reservations, there's operational and capacity risk. Are you impacting your workloads? Are you impacting customer workloads? Or what are you exposing yourself to by going into the public on-demand pool? There's also financial risk here, right? EC2 RIs offer a significant savings over running on demand. And then on the over-provisioning side, there's opportunity cost, right? Where else could you be spending that money in your organization? Where else could you be provisioning those resources, either inside your IT budget or adapting your IT budget elsewhere? And so what we see a lot of is folks over-provision like this. To get outside of the capacity risk or the operational risk, you'll see large over-provisioning like this, but that's a really expensive proposition to carry around that excess slack. One of the beautiful things about cloud is that you should be able to have a dynamic and relatively elastic footprint, which is where we get to here. With convertible RIs, if you have the right information, if you're looking at your cost and usage reports, you're looking at your DBR, you're monitoring what your on-demand versus reserved instances look like, you can actually have a step function that covers and is much closer to your actual demand. That's not easy though, right? You have sort of three primary issues when it comes to that optimization. There's access to the data. The folks typically who are empowered to make those large financial decisions around capacity planning and RI management often don't have the technical skills to go and query the cost and usage report or have the appropriate skills to do the RI to EC2 consumption matching. And the folks who do have that often don't work in the FP&A or capacity planning group. There's a scale problem. AWS cost and usage reports, DBRs, and CloudShell logs exceed the ingestion, manipulation, reporting capabilities of most off-the-shelf analytics options out there. And then the AWS cost and usage dashboard itself has very limited functionality. Once you get to scale, you're not able to manipulate the data appropriately. You can't combine it there with any other information you'd like to enrich for analysis, et cetera. And finally, time to action. It takes time to first get the data, use it all, and then produce actionable insight. So this is an example of how we use Looker to help close that gap. Looker makes data access easy, repeatable, scalable, no matter who's looking. The complicated calculation of RI matching to EC2 consumption is taken care of one time, and you know it's correct. So the view on this screen actually gives you one of our detailed views on our EC2 capacity. And we can look at a given point in time by a given AZ for a given instance type and see how many reservations we have available, how many EC2 nodes are running on demand, how many are running reserved, our total consumption, and as well as some percentages on percent running on demand, percent running on reserved and excess reservations, so we can easily fine-tune our RI footprint. What's great too is this can be all wrapped up in an email alert or report heads out to the people who need to see it every day. At some point, you'll hit a scale problem though, right? So this is the way we operated for a long time, probably south of 30,000 EC2 nodes. Once we got a little bit bigger, we've adopted another approach, which is sort of reservation optimization at scale. So a lot of the framework's still in place. We're still ingesting our cost of usage reports, 85 million rows an hour into Redshift. And then we use Profit and some other statistical modeling tools to produce forecasts. We do a lot of review of these forecasts in Looker to make sure that they seem reasonable and accurate. And then we have a Heroku app that actually ingests those forecasts and executes the reservation buys and trades just ahead of demand. Looker is still a key part of this cycle though. So this view up here at the line level detail gives analysts insight into the particular account, instance type, AZ, et cetera, when the forecast was made, what model that our application selected for the forecast, and forecast results, so that as the machine is doing its ongoing trading and executions, we have good line level insight into the real world of what's happening. So that's the end of the Heroku bit. I'll answer any Q&A afterwards. Thank you.
Thanks, Taylor. So once again, my name is Fabio Beltramini, and I'm a customer success analyst at Looker. And in that role, I had the opportunity to work with a lot of customers and see the common challenges that they run into on Redshift. So I'm going to cover three important categories of strategies that you should all be implementing on your Redshift cluster: query optimization, demand management and caching, and query monitoring rules. So for query optimization, Looker has produced a block called the Redshift optimization block that's going to help you to more effectively optimize your queries. And it's going to do this in 5 ways. The first way is that it's going to be quick to install, just like Taylor was talking about time to value. So we've provided the code in a GitHub repository, and you can just copy our LookML into your instance. And within 5 to 10 minutes, you can have reports on your cluster and query performance. Once you have those reports, what you're going to find is that they allow you to identify and prioritize patterns. So rather than going in at the query level as you might with the AWS console, what the block is going to let you do is it's going to let you be more focused and more strategic in where you're spending your query optimization efforts. You're going to have a nice top-down view of what are the categories and patterns that overall need to be addressed within your cluster and your queries. But in true Looker fashion, once you have those aggregates and those high-level patterns, you're going to be able to drill down and see what queries contribute to a specific pattern. And once you have those queries, you can inspect and diagnose those within our block. So you'll be able to see things like how much data was being scanned for a query, how much network distribution was being done. You're going to have the query plan, but you're also going to have that query plan right next to details and stats about all the tables that participated in that query. So with the block, you're going to be able to quickly inspect and diagnose the cause of slow queries. And then once you've done that, you've also got Looker's knowledge and best practices. So you'll be able to access articles on our discourse. Coming up at Join in September, I'll be doing a deep dive on what are the common issues that cause slow performance and how to actually fix them. And you also have a dedicated customer success analyst. And your success analyst can look at your model and your Redshift performance reports and help you do things like choose the best distribution keys that are going to be most performant across your whole cluster, across your whole schema, and across your pattern of query workload. That's going to be the first category, query optimization. The next category is going to be demand management, and essentially identifying the patterns of demand and seeing what you can do to shift that around so that your capacity that you've got provisioned in Redshift is going to be sufficient. The block is also going to help you do that in reports, and it's going to help you identify things like when ETLs are copying data into your data warehouse, when PDTs or other in-database transformation tools are consuming resources, when scheduled content like emails are running, and how all of those 3 interact with your human real-time on-demand use cases so you can balance them out and minimize the perceived delay from your ad hoc and explorative queries. One example of a tool that you can use within Looker to optimize your demand is Looker's smart caching feature and data groups. What this is going to let you do is it's going to put Looker on top of your data warehouse, and Looker is going to recognize when one of your ETL cycles has completed and there's new fresh data in the data warehouse. And based on that, Looker will start populating an application level cache so that when users come into Looker and start using any repetitive types of content like dashboards, those queries are going to get recognized by Looker as having already been run since your ETL last completed, and they won't even hit your data warehouse. And finally, the last group of recommendations would be to implement query monitoring rules. So query monitoring rules are a little bit less known just because they were more recently launched. What they let you do is define custom rules, and these can be based on how long a query has been running, how much CPU time a query has used, how much the query has written to disk or read from disk, how much memory it's used, and more. And then what Redshift will do is it will continually check all of your running queries against your rules, and it allows you to do one of 3 things with matched queries. You can either log them, which is useful, but with Redshift, the Redshift block that I just showed, you'll already get lots of the information when you need it. Alternately, you can automatically kill those queries for when they're really consuming too many resources. Or what's the most attractive or interesting feature is you can move queries around from one WLM queue to another one. So for example, you could take something out of your default queue and move it to a lower priority queue. And with those 3 recommendations, you'll greatly be able to optimize your Redshift cluster. With that, I'm going to pass it over to Dylan to talk about security.
Awesome. Thanks, Fabio. Unmuted ahead of time this time. Okay, so I'm going to be discussing security and monitoring. And the tool we use to do this within AWS is Amazon CloudTrail primarily. And CloudTrail is a great service from AWS that provides security and DevOps employees with a whole suite of information to perform their jobs better. Once you enable once you enable CloudTrail in your AWS environment, you'll receive logs of each action taken by a user or by another AWS service. These logs include information such as who took the action, where and when the action was taken, what resources were involved, the status of the action, and much more. Once you get to using AWS pretty heavily, there's usually pretty large volumes of actions being initiated by users or, again, other services such as EC2, VPC, IM, Redshift, etc. That means every time someone queries a database, logs into the AWS console, encounters an error or takes any other action, it's going to be recorded as an event in CloudTrail. And that makes CloudTrail especially useful for a few use cases. One is monitoring the volume and type of use of each AWS service and user. You can then combine CloudTrail with CloudWatch to get immediate alerts when certain actions happen, whatever actions might make the most sense for your business need, such as someone trying to log in without multi-factor auth or anything else that might be a little suspect for your business. Also helps with governance, so helping to ensure users are only taking the appropriate actions and there aren't any loopholes or gaps in your permissioning. It helps with compliance, so meeting any regulatory requirements such as data location and movement. AWS actually has a nice list of how you can use CloudTrail to meet regulatory needs across a number of different industries, and that's just on their website. And finally, CloudTrail is also very good for auditing, which you can do kind of across the board here. You can track down any troublesome users or services, see where the most errors are being incurred, and look for things like modifications to security groups and other important permissioning aspects. But since CloudTrail provides so much information, it can be used very flexibly for a host of different use cases, whatever is most essential to your business need. For purposes of this webinar, I'm just going to walk through a few of the more common examples. And that kind of echo one of the points Fabio made. The reason we like to do this in Looker rather than within the AWS console natively is because you're a bit more limited just within the console. The console is great for aggregate reporting and for looking at recent events, but it doesn't really allow very granular or historic analysis. I believe you're limited to the last 14 days or so within the console. So to circumvent these restrictions and get to enjoy all the richness and flexibility of querying this data with SQL rather than a UI, we drop our CloudTrail logs into S3, just plop Athena on top of that, connect Looker to Athena, and then we can actually use Looker to execute these queries against all of our data for all time at a much more granular level. But to get into the use cases. So the first one is looking at errors occurring throughout your AWS environment. We can look at these errors at a user or a service level and answer questions such as which users or services are trying to take actions that are resulting in errors. And are those end user errors, or is that something I, as the administrator, need to go in and fix? Using Looker, we can then drill into any of these aggregations to find more context behind each event, including the resources being used, the timing, and much more. So starting with these two examples, on the left, we have a chart that shows the count of errors by each user. We've noticed spikes in access denied error types. It looks like a user or a group of users are trying to launch new EC2 instances and make modifications to IAM permissions in this case, but they don't have the appropriate authorization. So maybe that means we need to give them more permissions, or maybe that means we need to go give them a slap on the wrist for trying to do something they shouldn't be doing. Really whatever makes the most sense for your use case. And this visualization is definitely a simplified version of what you'd actually see. You'll usually have many more users and more error types. But either way, it's a nice display of who's incurring errors and what type they're looking at. On the right side here, we have a chart that shows the total errors by each service. So which services are incurring the most errors. In this example, it looks like we're getting the most errors from Athena and S3 right now. Maybe that means those services don't have the appropriate permissions to talk to each other and transfer data. So if you have some application that's being powered by programmatic queries against Athena, storing that data in S3, we'd be able to identify that error pretty quickly and easily here and then take the remedial action to get the services talking to each other appropriately. And it takes contextual knowledge of your business and your AWS environment specifically to properly interpret the meaning of all of these errors. But that shouldn't be a problem for anyone on your internal team with a good, strong working knowledge of your AWS environment. And those were just two examples that I cited on the last slide. The Looker block for CloudTrail provides a host of dashboards that highlights all sorts of areas where common errors occur. So those are just two common ones used as examples. Another use case, or another really good use case for CloudTrail is monitoring your login activity across users. So because potentially hundreds of logins are occurring every day, it's important to identify those that seem to be outside of the normal course of business. So some key components to examine with respect to logins include logins that occur outside of your normal network. So to do this, and you can kind of see this in the bottom right here, with the most common IP addresses tile. To look at those logins that occur outside of our network, we can examine the logins across all of our IPs and look for any irregularities, such as repeated failed logins from some unknown or unrecognized IP, which would be could be an indication of someone attempting to penetrate your security settings. And in this example, we have one IP that's a bit irregular, starting with the numbers 52. This could be outside of our normal network, so we need to investigate where those are coming from and why. And again, this is also something you can set up alerts for. So say anytime someone logs in from a network outside of your predefined network areas, then you can get an alert, to your email or phone or whatever the case is to let you know that. You can also look at it by geolocation. This is a really easy way to just visually interpret login information. Obviously, if you're seeing logins from geographic regions where you don't have operations or virtual clouds or machines, that login activity could be suspect and probably worth investigating a bit. Another example is logins without using multi-factor authentication. So this just highlights the number of failed attempts to log in using MFA. We probably want to understand why MFA is failing for these users. Again, we could drill down and see each of those users and what the reason for that failure was. So lastly, another common use case as recommended by the folks on the AWS product teams is auditing security group and IAM permission modifications. So there's a whole host of issues you can encounter when security groups get modified. For example, maybe you notice one of your periodic queries against Redshift or Athena or something is no longer running. Maybe the security group permissions for that database or for your user were modified by some other user. Or maybe your EC2 utilization for a certain group of instances suddenly shoots over like 90% or something really high, and there's no real logical business reason for that. In that example, you want to inspect the user groups that have access to that EC2 instance. In this example here on the slide, that's something that no one would ever actually do in practice, but we've opened an EC2 port to essentially zero the public web. We definitely want to take remedial action on that and close that port immediately if we saw that someone had done that. And again, just like with anything else in auditing your AWS environment, there's never going to be any silver bullet to help you solve all of your problems, but CloudTrail logs can help you trace back events to understand why certain actions were taken, why certain events happened, and what's ultimately driving those errors. And so with that, I will open it up to Q&A. And we have about 10, maybe 15 minutes for Q&A. If you haven't already, feel free to type them into the Q&A box in the bottom left of your screen. And I'll go ahead and moderate and start asking some questions of our presenters in just a second here. But before I do that, I just want to mention that we also have plenty of resources you can look at after this webinar to reference any of these blocks we've built, how-to guides, all that sorts of good stuff. And those are included in this slide deck, which is downloadable, which will be downloadable after the webinar. We'll send out emails to everyone, whether you're able to attend live or not, in the next few days, and you'll have plenty of resource links there. So with that, I will get into some Q&A here. So the first one we have is, does Redshift have an S3 connector? So I can go ahead and field that one. So Redshift doesn't have a direct connector to S3. However, there's tons of documentation online in AWS docs that provide sample scripts and processes to migrate all of your data from S3 into Redshift on whatever sort of periodic basis makes the most sense for you. So not a direct connector, but certainly very not difficult to do. Most customers probably do that, and there's plenty of information available online.
And for that question, I would also add Redshift has Spectrum. So with Spectrum, you can read from S3 as if it were a table in your Redshift cluster.
Yeah, great point. So if you maybe had a ton of historical data that you didn't want to keep updating and maintaining in Redshift, you could keep all of that in S3 and just keep your most recent data in Redshift, and then use something like Spectrum to query all of the old data. There's a few use cases like that that really make a lot of sense. It's a good point, Fabio. Thanks. Cool. Okay, next question. Generally speaking, what columns are best to apply sort keys and disk keys to? Fabio, you want to go ahead and take a stab at that one?
Yeah, so the easier one is maybe the sort key. So you're going to want to apply the sort key for one of two reasons. For a large fact or a lot of rows in it, you can use the sort key to limit scanning. For example, if you want to just query recent data, having the sort key on the timestamp or created date field is going to be the right choice, because you'll be able to quickly query for a slice of time and scan data for scan blocks restricted by that sort key. So that's going to be a good choice in a lot of situations about a large table that you want to restrict how much Redshift has to read from disk. The other way that you can use a sort key is to enable merge joins, and that's going to help keep the memory footprint of your cluster lower. And that's also going to be relevant for smaller tables as well. So whereas a smaller table won't benefit from the reduction in scanning, it will still benefit from being able to perform a merge join between two tables. And in that case, you want to choose a sort key that's going to be consistent with sort keys on other tables and your distribution key, which I'll talk about. For the distribution key, what you want to think about is making as many joins as is feasible co-located. So where both sides of a table, or both tables on both sides of a join are using the same distribution key. One of the biggest pitfalls that people run into when choosing a distribution key is that they assume that it already exists on the table. So kind of free yourself from that preconception and realize that sometimes you're going to want to distribute, a very granular fact table by some higher level dimension that might not natively be on that. For example, if you've got a restaurant database where restaurants have tables and tables have chairs, the chair entity might not have a table column, or it might not have a restaurant column. But if you add it, then all three of those tables could be co-located by restaurant ID.
Awesome. Awesome. Thanks, Fabio. Cool. Next question. Did we use a lambda function to load data from S3 to Redshift? Yes, you can definitely do that. I know Lambda has the ability to, or you can invoke Lambda functions whenever something new is dropped into S3. So you could set it up so whenever something's in there, you automatically pipe it into Redshift afterwards. Certainly possible. A lot of people do that kind of stuff. All right, next question. Aside from making better use of reserved instances, what are other common levers for cost saving? Taylor, do you want to take a stab at this one?
Sure. So I think the general theme of insight and access to your cost and usage report isn't just for EC2, isn't just for RIs, right? So your cost and usage report contains usage data on all of your resource types. So you can perform, even without the lever of a reserved instance, you can perform the same provisioning versus actual demand in aggregate across all of your resources, whether that's, if you look at, you have an EBS optimized instance, or you're actually using that volume appropriately, it basically applies to any product.
Awesome. Great. Okay. What is the difference between reserved instance coverage and reserved instance utilization? So I can go ahead and field that one. Reserved instance coverage is essentially out of the amount of total hours of usage you're getting out of AWS, how many of those are reserved or are used with a reserved instance. So say you have 10,000 hours of EC2 usage in a month, to have 8,000 of those are based off of reserved instances, then your RI coverage is 80%. But your utilization, say you purchased those 8,000 hours, but you only ended up using 6,000, a different example, then your utilization would be the total amount of used RI hours over the total number of purchased RI hours. So 6,000 over 8,000, so 75%. All right. Security analysis is usually done in real time. How real time is Looker and CloudTrail? Great question. So within the AWS Console, CloudTrail, I believe, is near real time. I think it's down to 10 minutes, but don't 100% quote me on that. We can go onto the AWS docs and find out for sure. I know that with the pipeline we use of dumping all of the CloudTrail logs to S3, they're dumped about every 5 minutes. So our data in Looker that we're querying is also updated every 5 minutes. Okay. Does Redshift work with BI tools like Jaspersoft and Burst as a data source in creating their workflows? I'm not super familiar with either Jaspersoft or Burst's capabilities with Redshift. I'm assuming there's some compatibility. I don't think it's going to be the same architecture as Looker where they're directly executing queries against a database kind of on the fly based on the modeling layer. So I don't think they're going to be able to necessarily leverage the performance and the power of all of these of Redshift with one of those tools versus using Looker, which is querying directly. I'm not sure if that answers your question, but that's the best I got for you. All right, and we are coming up on time here, so we will do one more. All right. What's the most common reason you see Redshift queries running slowly? Fabio, do you want to go ahead and take that one?
Sure. So to be honest, it can be a lot of things, but if I had to pick one, it might be improperly written queries, but let's assume you have a properly written query. Then it's probably just having to distribute data around the network, for which you would configure the distribution keys on different tables to minimize network activity.
Great. So similar answer to your sort key and disk key question earlier. Awesome. Well, that's about all of the time we have here. Again, we have these resources. We have some resources available for all of you guys. We will send out a recording and the slides in the next few days. In the back here, you'll find more information on both Looker for AWS, which has information about these blocks, and a lot of our other work we've done with AWS in general. And then we also have some more information on just Looker in general. So if you're looking to give Looker a try, maybe outside of the context of just AWS, we work with any SQL compatible database, but certainly love working with Redshift and clearly have a good positioning with all the AWS tools. So with that, I'll go ahead and call it. And thank you all for attending. And we look forward to hopefully interacting with you in the future. Thank you.